So for this video, we're going to learn about the interior and exterior angle theorems for polygons. And our objectives are: I can state and use the interior angle theorem, I can find the sum of the interior angles of a polygon, I can state and use the exterior angle theorem, and lastly, I can find the measure of individual interior and exterior angles. So we'll begin with the interior angle theorem for polygons. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180 degrees, and here n is our number of sides, right? That's what an n-gon means. So the number of sides minus 2 times 180 degrees. And for quadrilaterals, we know the sum of the interior angles of a quadrilateral is 360 degrees. So we'll quick just plug in the math to make sure that works. So a quadrilateral has 4 sides minus 2 times 180 degrees. 4 minus 2 is 2. 2 times 180 equals 360 degrees. So next we're going to classify this polygon and find the sum of the interior angles. So this is a 8-sided figure, right? We can count them. And an 8-sided polygon is an octagon. So now we are going to try and find the sum of the interior angles. So an octagon, like we said, is an 8-sided figure. So 8 is going to be in for n. So 8 minus 2 times 180 degrees. 8 minus 2 gives us 6 times 180 degrees. Do that math. And that comes out to be 1080 degrees. Okay. Next, we are giving you the sum of the interior angles of a convex polygon, and it is 900 degrees. And we want to classify the polygon by the number of sides. So in this one, if we were to have our formula, we would have n minus 2 times 180 degrees and we can set that equal to 900 degrees. So our first step is to divide by 180. Divide by 180 on both sides. So then we have n minus 2 equal to 5. So we add 2 to both sides. And n is going to equal 7. And so if our polygon has 7 sides, it is a heptagon. Okay, moving on to the exterior angle theorem for polygons. And the theorem states that the sum of the measures of the exterior angles of a convex polygon, and we need to make sure this next part is important, with only one angle at each vertex, is 360 degrees. So if we are going to do that, we need to make sure that we only make one angle at each vertex. Okay, so if we're going to use this angle, we can't use this one over here. So you just need to make sure you only use one angle at each vertex. And to help you better visualize this, look at this diagram. So if we draw an exterior angle at each vertex, so we just extend every side length, and if we choose this angle, we have to choose that angle for each one. We can't be using this one. So we have our 5 angles on the outside, and if we were to cut these out along the lines and get these angles, if we put them all together with all their vertices being joined at the center right here, we'd see that it would make a whole 360 degrees. So if we go back and look at this, the sum of the measures of exterior angles of a convex polygon is 360 degrees. So, quick review. What is the equation for the interior angle theorem? And also, what does n stand for? So we have n minus 2 times 180, and n equals the number of sides. Okay, make sure that you do your reflection, get those points, ask any questions if you need to, and we will see you tomorrow.